Why did the boy keep a ruler under his pillow? To see how long he could sleep. And for this last lesson, I decided to use just a regular joke. Well, because I was looking for a probability joke and I wasn't sure I could find one. You think I could find one? Probably. Get it? Oh, 2 for 1. Anyways, let's go ahead and look at something you learned in 6th grade, which is independent and dependent events and sample spaces and tree diagrams. So we're going to look at a problem where you're ordering sandwiches for your club social, and you need to choose between wheat bread and panini bread. And you can also get a turkey, ham, or vegetarian. So how many different sandwiches could we make? Well, what I have here is the start of a sample tree. I'm going to start with my first choice, which is bread. And what are my two choices? Wheat and panini. After I pick wheat, then I have 3 choices for filling: turkey, ham, and vegetarian. Same thing for the panini. I have turkey, ham, and vegetarian. So you can see how many different sandwiches can I make? 6 total sandwiches. So I can make this to write a sample space, and I just say wheat and turkey, wheat and ham, wheat and vegetarian, panini and turkey, panini and ham, and panini and vegetarian. So what is the relationship between the number of choices and the number of sandwiches? The total number of sandwiches is a product of the number of choices for my first choice, which is bread, and for the fillings. So I have 2 choices for bread, 3 choices for fillings, so I have 2 times 3, 6 total different sandwiches. This is called the fundamental counting principle. If there are A ways for one activity to occur and B ways for the second one to occur, then you just multiply A times B to figure out the total number of ways for both of them to occur. In this example, Annalena is taking 2 rides at Fiesta Texas. She likes the Boomerang, their Twister, and the Goliath. So we're going to create a tree diagram and determine the number of possible outcomes. And she is allowed to take a ride more than once. So start off with the Boomerang, their Twister, and Goliath. And then I branch out from Boomerang and add all 3 again, because she's allowed to do all 3. And the same thing for the others. So you can see we have a total of 9 choices here. Boomerang, 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 Twister, Boomerang, Goliath, etc. So the number of total possible outcomes is 3 times 3, which is 9. So for further reflection, how do you make a tree diagram? Start with a list for your first choice, okay, and I like to do it in a column. And then from that column, go and pick the number of choices you can make based on that one. For independent probability, which is what we study a lot, the number of choices won't depend on the first column, but we will be doing some problems later that are dependent, and it does depend. And then what is the shortcut to determine the number of outcomes for composite events without creating a tree diagram? Well, if you know you have, say, 4 choices for the first thing and 5 choices for the second, you just multiply them together to get 20. So you don't have to make all 20 outcomes for the sample